Classification. So we're going to use classification for identifying and grouping different organisms. And as you can see from this poster, that is a handy skill to have. All right, taxonomy is the idea of arranging things. In science, we like to put things into groups. So the science of identifying and classifying organisms, living organisms, that is talking about taxonomy, or previously living organisms. That is going to be referred to as a taxonomy. And by classifying these organisms into different groups, it'll obviously help us identify them, but then also looking at the similarities and differences between those groups is going to help us understand those organisms better as well. Carl Linnaeus was one of the earlier people to formalize this system and popularize the system, and he was grouping things according to structural similarities. He came up with what is now known as binomial nomenclature, the idea of using two names, and this became the universal naming system in science, and is known as a scientific name. This then sort of morphed into a larger system of classification, which we're going to be using, and it involves several different layers or levels of classification. So here they are here on the right, and each layer is called a taxa. So the most general layer that we're going to start talking about is going to be the kingdom. So the kingdom of things that we're talking about will have the most amount of organisms in it. And then within a kingdom, there's going to be several different things, and those individual groups within a kingdom, we're going to refer to those as phylum. So a kingdom has all sorts of different organisms in it. They can be put into groups, and those groups themselves are called phylum. The phylum can be made up into several different groups, and each of those groups is called a class. And that can continue into an order, a family, a genus, and then finally getting down to a particular level, which we refer to as species, and that's going to be the most specific of those levels. So most broad at the top and most specific at the bottom. And there are other intermediate ones, so you can have sort of these sub-levels within them that you might see depending on what type of organism you're looking at. So there are intermediate taxa that are out there, super and sub, the big above it or below it. We're going to stick to these main ones here, though. Here's a mnemonic that can help you remember it, but King Philip came over for good soup is one particular way. Just remember the order of the letters that they come in: kingdom, phylum, class, order, family, genus, species. And this can be used as a comic device, as is done with the Roadrunner and Wile E. Coyote here. The idea that you would have a two-part name that describes some characteristic of the species, and those names do tend to be Latinized in some way or another, and so this has been used to great device within the Roadrunner cartoon. All right, just a quick recap that a species is a group of organisms with the ability to reproduce with one another and produce fertile offspring. So if a group of organisms are able to do that, we refer to them as a particular species, and that's the most specific level that we're going to be dealing with. A genus is a group of species. So if you have a different type of species, so one species and another species that are different species but share some characteristics, they might be put into the same genus as each other. So for example, when someone talks about referring to bears, that is a particular genus. And so there are several species of these bears. So there's the polar bear, and there's the grizzly bear, and the black bear. And so they have their own species, but they share similar common characteristics. So they fit into the same genus, or orchidaea. Because they are themselves their own species, a grizzly bear and a polar bear would not be able to breed and produce fertile offspring because they are themselves different species. So our definition corresponds to the differences in those two different groups. Polar bears and grizzly bears are different enough that they cannot produce fertile offspring. So therefore, we refer to them as two separate species. But those species fit together into a more general group called a genus. Family is going to be even more general than that. So if you have a number of different species that are within a genus, you can have a number of different genuses that fit together within a family. So if you ever refer to, I don't know, going to a flower shop and buying an orchid, you're probably being fairly general in your description of the flower. That description fits into a full group called a family that refers to the orchids. And within that family, there would be specific genuses with the specific species, but the orchids themselves is that particular type of classification is a family level classification. And then getting more and more general, families get grouped into orders, orders get grouped into classes, classes get grouped into phylums, and phylums get put together into kingdoms. So a kingdom is going to have several different phyla within it, and then later we're going to be talking about 6 major kingdoms. So here's us as a particular species. You know that we are referred to as using our binomial nomenclature name, Homo sapiens. And the way binomial nomenclature works is that we mention our genus with a capital, and then our species uncapitalized and normally underlined or in italicized letters. So our species is sapiens, our genus is Homo, and our family is Homodea. And if we keep getting more and more general, we can see that the kingdom that we're in is Animalia. Within the animals, there are things that have backbones and things that don't. The group that has backbones gets classified as Chordata. Of all the things that have backbones, there's some that are warm-blooded and produce milk and have fur. Those guys get into grouped and given the name Mammalia, mammals. And with all the mammals, there's a particular group that have certain characteristics that we call primates. And then of the primates, there is a certain group of those animals that are primates that have certain characteristics that we call the Homodea. If we look at our relatives, these guys here, so we would know them as chimpanzees, but their scientific name is Pantrygloides, and so that is their genus and species. So their binomial nomenclature name, their binomial name, scientific name, mentions the genus and then the species. And you'll notice that they are in the same family as us. If you go back to us, there's the Homodea. We share all the similar groupings of chimpanzees up to the point of family. So they're in the same family as us, but they are not the same genus as us, nor are they the same species as us. They are in a different classification group. Here's a visualization of that. Here's our species as sapiens, and there used to be other members of our genus that were around that are no longer around. They're extinct right now. But there used to be other members of our genus. Right now, we're the only ones. But if you go back up to the generalization of family, that is essentially what's known as the great apes. And so we do still have members of that family around. So a gorilla and a chimpanzee and orangutan, they all fit into the same family as us as great apes. And if you go one more level in terms of general, you can get up to primates, and then we would share even more characteristics with all the members of primates, like the lemurs and the tarsiers and other lories and other monkeys that are around. They would all be primates, of which humans fit into that classification group. Here it is here with bears. So if we look at within the kingdom Animalia, there's a very small representation of it. But if we look at, so the wrong one, let me get rid of that. Animalia here. So this kingdom has all of these guys in it. So grizzly bears are animals, and red foxes are animals, and coral snakes and sea stars. They all fit into the kingdom Animalia. Plants would be in a different kingdom. Then within that kingdom, there is a phylum called Chordata. So that is all these guys here. You'll notice the one that got excluded out of our phylum, or this bear's phylum anyways, were the sea stars. Sea stars don't have backbones, so they don't get included into the more specific layer, in this case, of chordates. And then Mammalia, no, my picture doesn't quite line up with the words here, but we'll do our best here. These guys are all mammals. The snake got excluded because it is not a mammal. There's an order within the mammals, Carnivora, I think it is, and in that particular group, squirrels are not included, so they have a different morphology than the other members of this particular order. And then we mentioned the bear family, which would have all these guys in it, but not foxes, just the bears. And then within a particular genus, you have fewer members in there. And then you get right down to Ursus arctos. That is one particular species. And so we have the kingdom, the phylum, the class, the order, the family, the genus, and the species, getting more and more and more specific. Kingdoms have the most in it, and then as you specify, we can move down the levels of taxa. So binomial nomenclature, each organism has a genus and a species in their name, and we refer to that as the scientific name. So the scientific name are italicized or underlined, and the genus, the first letter of the genus is capitalized, the species is all lowercase. Sometimes it can be simplified where the genus is not written out in full and is just mentioned as a particular capital letter. So lynx canadensis is the Canadian lynx, and sometimes you'll see it written as just L. canadensis, where the L is representing the genus, and then the species is being specified. So a dichotomous key is one of the tools we can use to classify these organisms, because it's easy to have a system of classification, but then when you have the organism showing up in front of you, trying to fit it into that group may be a little bit more difficult. So a dichotomous key can help us to identify these organisms, and it can work kind of like a decision tree, or at least like a series of steps to follow. So here's a series of lists here. We have a bunch of birds. So let's say, imagine you see 4 different birds flying around and you want to know which type of birds they are. You could use a previously built dichotomous key to figure out which bird is which. And you'd go through and you look at the characteristics of the bird, and then you'd use the description on the dichotomous key to say which type of bird it is. So the first one says the beak is relatively long and slender. And if that is the case, then this is the particular type of bird you're dealing with. If the beak is relatively short and heavy, then you're going to go to the next step and you're going to follow it through. So this is one listed way of doing it. And this is a little bit more visual way of seeing it. So this works in the same way, but instead of listing the descriptions of the organisms as a list, they're drawn out as a table, which is a lot easier to follow. So this is a very concise one. You can put more wording in to make it a little bit easier to use. But essentially, imagine you had these 4 different organisms. You didn't know what they were. Someone could set up a dichotomous key to help you identify which one was which. So they could say, okay, well, first of all, does this organism have feathers? And then it's set up, it's called dichotomous because you have 2 options. You can say, yes, it has feathers, or no, it doesn't have feathers. So let's say we're trying to identify this organism up on the left here, or whatever it is. We could say, okay, well, does it have feathers? And you look at it, and then, nope, doesn't have any feathers. So you go this way on the dichotomous key. The next question is, does it have legs? And nope, doesn't have any legs. So then you go with the no side and say, oh, that's a snake. Whereas if you looked at this guy right here in the top right, you could say, okay, does it have feathers? And looking at it, there's some feathers there. So it goes to this side and say, okay, well, does it swim? And nope, this guy doesn't swim. The other guy does, but this guy up here doesn't. And so you'd say, no, it doesn't swim, therefore it must be a hen. So essentially you're asking yes and no questions that become more and more specific and divide the group into smaller and smaller groups until you get to the specific name of the organism that you're looking for. Now, obviously, this isn't using binomial nomenclature or scientific naming. This is a very simple one, but the idea is you're using yes or no or very simplistic questions to divide the groups into smaller and smaller portions until you get down to the level where you can identify the individual.